Have you ever looked up at the night sky and wondered where stars come from? Their origins are hidden in cosmic nurseries called nebulae, vast, colorful clouds of gas and dust where new stars are born. Imagine drifting through a nebula, surrounded by swirling pinks, blues, and purples, like floating in a dream. Each nebula is unique, quietly shaping the future of galaxies. Thanks to nebulae, new stars are always forming, lighting up the cosmos. Even our own sun was born in such a place. So next time you gaze at the stars, remember the nebulae, the cradles of cosmic life. Space clouds aren't like the ones in our sky. They're much, much bigger. Star-forming nebulae, or molecular clouds, are the largest in the universe. Some stretch hundreds of light-years across, trillions of miles wide. You could fit thousands of solar systems inside just one. These clouds are packed with hydrogen, the main ingredient for stars. They're cold and dense, allowing gas and dust to clump together over millions of years. It's like a cosmic snowball, slowly gathering mass. Why so big? It takes a huge amount of material to make stars as massive as our sun. These nebulae are the universe's warehouses, storing enough gas and dust to create entire clusters of stars. Their immense size is crucial. They need enough gravity to start the star-making process. Without their scale, the delicate balance of gravity and pressure wouldn't work. These clouds are the star factories of the cosmos. From a single nebula, hundreds or thousands of stars can be born. Their vastness is directly tied to their role in lighting up the universe. The universe designed these colossal clouds for one grand purpose: to create new stars. They are the engines of cosmic renewal. Without them, galaxies would go dark. Thanks to these giants, the cycle of star birth never ends. They are the true architects of the night sky. How does a cloud of gas and dust become a star? Think of it as cosmic baking. The main ingredient is hydrogen, and gravity is the oven. A shock wave or collision stirs the cloud, creating dense clumps that pull in more material. These clumps spin and flatten into disks, with a dense center called a protostar. As pressure builds, the protostar heats up. When the core gets hot enough, nuclear fusion ignites. Hydrogen fuses into helium, releasing energy. This is the birth of a true star. The leftover disk forms planets, asteroids, and comets. We are, quite literally, made of stardust. The next time you see a star, remember, it was baked in the heart of a nebula, and we are all part of its grand recipe. Star-forming nebulae dazzle us with their colors, a cosmic rainbow captured by telescopes. These colors aren't just for show, they reveal the chemistry of the nebula. The most common color is red, from hydrogen gas excited by young stars. When hydrogen atoms absorb energy, they glow with a signature red light. Blue comes from starlight reflecting off dust, just like Earth's blue sky. Reflection nebulae scatter blue light, creating brilliant patches. Greens and oranges come from elements like oxygen and sulfur, each glowing in their own way. By studying these colors, astronomers map out the nebula's composition. The colors tell us where hydrogen, oxygen, and dust are found. It's a beautiful picture, and a scientific treasure map. Every hue is a clue to the nebula's secrets. The universe paints with light, and nebulae are its masterpieces. These colors connect us to the chemistry of creation. The next time you see a nebula's photo, remember, you're looking at the language of the stars. The Pillars of Creation, one of the most iconic images from the Hubble Space Telescope. These towering columns of gas and dust rise within the Eagle Nebula, each several light-years tall. They're being sculpted by the intense radiation of nearby young stars, slowly eroding away. Inside their shadowy depths, new stars are forming, hidden in dense pockets called eggs, evaporating gaseous globules. The pillars are both being destroyed and creating new life at the same time. It's like watching sand castles dissolve as the tide comes in, while new castles are built within. Some astronomers think the pillars may already be gone, destroyed by a supernova thousands of years ago. Because they're 7,000 light-years away, we see them as they were millennia ago. We might be looking at a ghost, a beautiful structure that no longer exists. The pillars of creation remind us that the universe is always changing. Starbirth is messy, chaotic, and fleeting. Yet, in these cosmic ruins, new stars are born. The cycle of creation and destruction never ends. Now, let's visit the Carina Nebula, one of the largest and brightest in the sky. Visible only from the southern hemisphere, it spans over 300 light-years. The Carina Nebula is home to some of the most massive stars in our galaxy, including the unstable giant Eta Carinae. Eta Carinae is 100 times more massive than our Sun, and millions of times brighter. Its violent eruptions have shaped the surrounding nebula, creating features like the Homunculus Nebula. The Carina Nebula is a wild landscape of glowing gas, dark dust, and brilliant star clusters. Mystic Mountain, a 3 light-year tall pillar, is one of its most famous sights. Jets of gas stream from infant stars hidden within these peaks. The nebula is a battleground. Massive stars carve out bubbles and trigger new waves of star birth. These stars live fast and die young, exploding as supernovae after just a few million years. Their deaths enrich the galaxy with heavy elements, ingredients for planets and life. Studying Carina helps us understand the origins of the atoms that make up our world. It's a place of beauty and scientific discovery. The nebula's chaos is the engine of creation. Here, we see the life cycles of stars in action. The Carina Nebula is a cosmic laboratory, revealing the secrets of stellar evolution. It's a reminder that even in chaos, the universe creates wonders. Next, the Trifid Nebula, a favorite among astronomers. Located in Sagittarius, about 5,200 light-years away, it's named for its 3-lobed appearance. Dark dust lanes split the nebula into 3 glowing red sections, like a cosmic flower. The Trifid Nebula is a rare combination: emission, reflection, and dark nebulae all in one. The red glow is hydrogen gas lit by young stars. The blue is starlight reflecting off dust. The dark lanes are thick clouds blocking the light. This nebula is young, just 300,000 years old. At its heart, a cluster of hot, young stars powers the glow. Infrared telescopes reveal protostars and stellar jets hidden in the dust. The Trifid shows star formation at every stage: massive stars, newborns, and the next generation in the making. It's a family portrait of cosmic creation. In one view, we see the entire star birthing process. The Trifid Nebula is a compact, beautiful summary of how stars are born. Now, let's travel to the Tarantula Nebula, far outside our Milky Way, in the Large Magellanic Cloud. At 160,000 light-years away, it's the most active star-forming region in our local group of galaxies. Its glowing filaments resemble a spider's legs, earning its name. At its heart is the superstar cluster R136, home to some of the most massive stars ever found. These giants pour out intense radiation, shaping the nebula and triggering more star formation. The Tarantula Nebula is a frenzy of creation, a runaway process where new stars spark even more births. It's so bright that, if closer, it would cast shadows on Earth. This nebula is a window into the early universe, showing us how stars formed in different environments. The Large Magellanic Cloud has fewer heavy elements than our galaxy, making it a unique laboratory. Studying the Tarantula Nebula tests our theories of star formation. It's a place of extremes: mass, brightness, and activity. The tarantula is the heavyweight champion of star nurseries. Here, the universe weaves a web of new stars. It's a cosmic spectacle of birth and energy. For our final stop, let's visit the Flame Nebula in Orion, one of our closest star nurseries. About 1,400 light-years away, it glows with fiery orange and yellow hues, streaked with dark dust. The energy comes from Alnitak, a hot blue supergiant in Orion's belt. Alnitak's ultraviolet light makes the hydrogen gas glow, while dust lanes block some of the light, creating the flame effect. The Flame Nebula is incredibly young, a stellar delivery room. Hidden behind the dust are hundreds of newborn stars, just 200,000 years old. Many are still surrounded by disks of material that could form planets. Infrared telescopes let us peer through the dust to see these baby stars. The Flame Nebula is a snapshot of star birth in action. It's a reminder that the universe is always renewing itself. Orion, steady in our sky, is actually a place of constant creation. The Flame Nebula is a symbol of cosmic renewal, a fire forging new suns and worlds. The cycle of birth and creation continues, lighting up the universe with new hope.